In example 1, we have a situation where Kelly is about to start college, and her parents want to set aside some money for her so that she can make quarterly withdrawals of $1,000. So Kelly will be able to withdraw $1,000 at the end of every quarter for the next 4 years. The account that they are depositing the money in earns an 8% annual rate of interest compounded quarterly. So the question is, how much should Kelly's parents deposit to make sure that Kelly is able to make these withdrawals? This is an annuity problem, so we're going to start by identifying our 8 variables: PV, FV, etc. Okay, so PV, FV, PMT, M, R, I, T, and N. Okay, so we know that Kelly's parents would like her to be able to withdraw $1,000 every quarter. Since this payment is recurring, that $1,000 withdrawal is recurring, that's going to be our PMT. So the payments happen on a quarterly basis over the course of 4 years. So T is 4 and N is 16. There are 16 quarters in 4 years. Our annual interest rate is 8%, which means the quarterly rate is 2%. And we want the account to be empty at the end of the 4 years. Basically, we are going to have just enough money for Kelly to be able to make these 16 withdrawals, and then after that last withdrawal, the account will be empty. So the question is, what should the PV be? How much should be deposited? Okay. So again, this is a decreasing balance annuity. The payments here are going to lower the overall balance of the account. So the formula we use for such an annuity is FV equals PV times 1 plus I raised to the n minus PMT times 1 plus I raised to the n minus 1 divided by I. This is a little bit different from the annuity formulas we saw in the previous section because of this minus sign. But the reason we have a minus sign here is because this is a decreasing balance annuity. So plugging in the relevant variables, we have 0 equals PV times 1.02 to the 16th minus 1,000 times 1.02 to the 16th minus 1 over 0.02. Doing some calculations here, we get that 0 is equal to PV times 1.372786 minus, now I'm going to calculate, I'm going to calculate all of this, and then if I do that, I'm going to get 18,639.28525. Okay. So now to solve for this, I need to move that minus 18,639 over to the left-hand side, and then I'm going to divide by the 1.37 and so on. So I get 18,639.28525 equals PV times 1.372786. Okay, so then I divide both sides by 1.372786, and I find that the present value, or in other words, the amount that the parents have to deposit, is $13,577.71. It's worth noting that even though the parents only put in approximately $13,600, Kelly is actually going to make 16 withdrawals of $1,000 apiece, so she's going to take out $16,000 total. The difference between those two numbers, $16,000 and the $13,600, would be the amount of interest that was earned on the account over the course of the 4 years.